All right, if we take a look at what we dealt with yesterday, and I asked you to just deal with some graphs and note the amplitude and period. And if we take a look at the indications of our equations, what we want to get back to, or what is we want to get back to the idea of what you've done for right now is you've plotted values of theta and y and just plotted the points, which is like making a little t-chart. We want to utilize the idea of making this a little bit easier on our slope self, where I can say my slope is a value of 2 and my y-intercept is a value of 3, and I can graph my equation of the line by looking at my slope and my y-intercept. So if we look at our three graphs from yesterday, 1, 3, and 5. We looked at our graphs, and if I looked at my first problem we did, our amplitude was a value of 1, and the period was a value of 360 degrees. The third graph we graphed yesterday, the amplitude came down to a value of 2, the period came down to still 360 degrees. The very last graph we did yesterday, the amplitude was a value of 3, the period was 180 degrees. Now what you had to do for homework in problems number 2 and 4, ask you to note what is the amplitude and the period. Well, in the in problem number 4, the amplitude came down to a value of 4, the period came down to 360. The one you may have struggled with a little bit is the last one here, y equals sine 3 theta. You would have to use other values like 30, 60, and 90 to be able to determine that. But if you did, what you were able to come up with is the amplitude is a value of 1, and what happened was the period came down to 120 degrees. Now what we want to be able to do is by inspection look at our equations and determine these amplitudes and periods. Well, if I take a look at a general equation, when I had 1 sine of theta, amplitude was 1. When I had 2 sine of theta, the amplitude was 2. When I had 3 sine 2 theta, the amplitude was 3. When I had sine of 4 theta, amplitude was 4. When I just had sine 3 theta again, my amplitude went back down to 1. So what we can determine is by looking at our equations, the coefficient of our trig function ended up being our amplitude. So if we start formulating, I'm going to use the value of A for the amplitude, and this is not going to matter if we're talking about a sine or a cosine, but our coefficient that's out in front of our trig function will end up being what our amplitude is. That's the easy one. The more difficult one is the period. When I had just sine of theta, I had 360. I had sine of theta, I had 360. But when I got 2 theta in there, period was 180. Sine of theta, still back to 360. But when I had 3 theta, the period was 120. So the question is, if I look at this coefficient, which is, if I don't have anything there, a value of 1, what can we do with this coefficient to be able to come up with the period? Well, when it was 2 theta, it was 180. When it was 3 theta, it was 120. When it was just theta, it's 360. So what we can do is we can look at this coefficient B, I'm going to call this B, and of theta, our B theta. And if we take a look, this period is going to look like 360 degrees divided by this B value. So when I had 1 there, 360 divided by 1. When I had 2 there, 360 divided by 2, 180, 360 divided by 3, 120. So I came down to a value. If we looked at all these graphs with respect to sine, they all have a common point between every one of the graphs. If you look at problems 1, 3, and 5 that we graphed yesterday, and then problems 4 and 6 in the homework, there's a common point between all of them. And that one common point is 0, 0. Because if I take the sine of 0, I'm going to get 0. Well, if I take 3 times 0, I still get 0. If I get 4 times 0, I still get 0. If I have 2 times 0, I get 0. So I'm still taking the sine of 0. So no matter what value is, or what value I'm dealing with here with my coefficient of b, I have a common point of 0, 0. So if we take a look at y equals 4 sine 2 theta, we want to take a look at the amplitude and period, but now we want to just take a look at this by inspection. If by inspection we look at this, my amplitude would be a value, period would be a value, go ahead and find those values. Amplitude should be value of 4. The period is, my b value is 2. 360 divided by 2, or 180 degrees. So looking at our graph now, if we take a look at our graph, we have to go back and utilize our ideas of definitions. When we look at the idea of definitions, we have this common point, which is I'm going to call my starting point as 0, 0. And if we go back to look at our definition, the definition of a period is the number of degrees in the cycle. Definition of a cycle is the point on a graph to another point in the graph where the graph starts to repeat itself. So if I'm at the value of 0, that means every 180 degrees in either direction, I will be back at that value of 0. So we will be there at 0. What we will play at this point is what I call games of halves. The halfway point between 0 and 180 degrees. Well, what we have to look at is the characteristics of the sine curve. Every one of our sine curves started at our neutral axis. We click, 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 click. We climbed the hill. Once we climbed the hill, we got to the peak, and then we went into scream mode. Ah! Underneath this neutral axis. So we screamed, and then we came back up again. Well, this is one cycle. This is 180 degrees. My games of halves are these halfway points. So halfway between 0 and 180 degrees. We will get 90 degrees. We will be on this prime axis again, or on the neutral axis. My games of halves. We have 45 and 135. My halfway point between 0 and 90 degrees. We will be at our peak. Well, where our peak comes from is right here, is our amplitude is a value of 4. Then halfway between 90 and 180 is 135. We'll be down at our valley. So we can get our sine curve. One thing I'm going to adjust with the amplitude. Amplitude will be the absolute value of this A value. So if we look at the next one, my amplitude is going to be the absolute value -2, which is the value of 2. Period 360 divided by 3, or 100, 120 degrees. We look at our graph. We have theta, we have y. I'm going to count out by 30s here because the period is not very big. So we have 30, 60, 90, 120, 150, 180. My amplitude is 2, so I need to max out at a value of 2. Our starting point for sine curves, always on the axis, neutral axis. Period's 120 degrees. Every 120 degrees, we need to be at the exact same value. So at 120, we're there on the neutral axis. Our games of halves, halfway between, will be 60. Here's where the negative comes in. We look at negative as a -2, but we can also call that the opposite of the 2. So what we have to deal with is the opposite of what we normally would have. So what the opposite would be, rather than climbing the hill first, we're going to go down first. Down to 2. Then our games of halves, halfway between 60 and 120 is 90. We'll be up at the value of 2 then. So here is our sine curve. Okay, and we're not going to go through this because it's going to be the exact same throughout. So if we take a look at our amplitude and period for here, our amplitude, a value of 3. Here's our B value. The period is going to be 360 divided by 6, or 60 degrees. Now looking at the cosines, all of our cosine curves, we have a common starting point for all the cosine curves at the theta value of 0. If we look on the y-axis for every one of our graphs, where we start with our y value for each one of our graphs is we will either start at a peak or a valley. We start at the amplitude. So if you look at all the cosine curves we did, we started at our amplitude. So at the theta value of 0, we're going to start up at 3. Period of 60 degrees, which means every 60 degrees we'll be at the exact same spot. So if we go out to 60, we'll be back up at 3. We play our games of halves, halfway between 0 and 60, we'll be at 30. What a cosine curve will look like is we start at the hill, we scream "Ah!" underneath, then back on top of the hill grid. So at the value of 30, our halfway point will be at our valley, which is at -3. These games of halves, 15 and 45, will be on our theta axis. So here would be our cosine curve. What I want you to try to do for your homework is try to go on page 45 and 46, problems 7 through 12, and start using the shortcut methods. Find the amplitude and period and see what you can get with your graphs. We'll add more to this on Friday and continue to working with us on Friday. All right, have a good day.